Welcome back to another session of Vibrometry Explained. I want to talk about one of my favorite features and capabilities of the PSV software, video triangulation. So we kind of go through some of the basics and then, explain what VT or video triangulation does. I call this one of the superpowers of PSV 3D. Um, why is it important? So, I guess it boils down to this one statement: accurate geometry is required for accurate in plane and out of plane component measurements. So, the first prerequisite and the most important prerequisite is good geometry. Now, in these two cases given on the right, which one do you think gives better geometry when your three beams are perfectly superimposed, as shown on the right, or when they are not? So obviously, it's this. It's not a trick question. So you want to kind of try to achieve the green thumbs up rather than the red thumbs down. So that's where video triangulation happens to be one of the techniques. So it's all about getting that accurate geometry. Accurate geometry comes from the fact that the three beams are superimposed. If they are not, then of course, it's going to affect your measurement, how the system calculates the x, y, z, the actual vibration amplitudes. So in the plot below, you see an example where the in-plane components could be measured higher than what they actually are with no video triangulation. Means if your beam overlap is not good, then it could result in you getting something like an overcompensation in the in-plane direction. Now, where does this become a big deal? In plane direction, high frequency measurements, high spatial resolution, tiny amplitudes. There, it can make a big difference. Small objects, where you're just inherently playing with smaller structures, where it becomes even more important that the three beams merge for the most accurate IP and out of plane measurements. Perhaps the most important is the strain measurements, where we are looking at small amplitudes to begin with, and then now we are looking at the difference to calculate the delta L. So here it becomes paramount that you have the absolute highest accuracy in terms of geometry, which would mean absolute highest accuracy in terms of the in-plane measurements required for strain calculation. There are three ways that I want to talk about today to measure the geometry and hence improve the quality of your overall measurement. Geometry scan unit, I'm sure you guys are familiar with it, or just with the 2D and 3D alignment, and then video triangulation. I want to show an example in the next slide. And as you know, geometry scan unit or geometry laser is it's not bad for large structures. For visualization purposes, it is fine, but one has to remember the inherent accuracy of the time of flight laser is plus minus 2 millimeters. So that's what you're playing with. So that's the top left case. And then here on the top bottom left, 2D align based on 2D alignment, much better, but it does depend on the number of points, the alignment points that you use and how accurate those are. The best, of course, is video triangulation, where you see we are going from millimeters of accuracy to microns of accuracy, where the beam positioning is perfect, which means the geometry is perfect, which is what you are seeing. This what you're seeing here is not video triangulation. What you're seeing here is the result of a good geometry. So it's a result of doing video triangulation that gives you good geometry and hence good in plane and out of plane measurements. Um, so here's an example. Video triangulation is basically the process of merging the three beams precisely as good as it can get on top of each other. And then once we do that, then the next step is, adjusting the scan mirror angles and hence changing the XYZ coordinates of those points. So it's basically improving the coordinates of each and every point by merging those three beams, and you can see the change here, before triangulation and now after triangulation. What we are doing is we are looking at the pixel intensity and doing some image processing to make sure that the three beams kind of merge on each other. So yeah, so step would be activate video triangulation, either do the geometry before or preferably during a scan, because if you do it during the scan, then you can rest assured that when you are actually making the measurement, you are getting the highest possible accuracy in terms of the beam overlap, which would in turn give you the highest possible accurate geometry, which would in turn give you the highest possible out of plane and in plane vibration measurement accuracy, which is the ultimate goal. So it's all connected, and it's all because of the power of our software development group, of course, and the power of image processing, considering the high HD camera we use. So I hope this helps. Video triangulation, super important, very helpful for getting the highest fidelity data. Until next time, stay tuned. Reach out if you have any questions or if we can help in any way. Bye bye.